Hi everyone, today we're going to study exponential growth and decay. This is an application of exponential functions. Exponential growth is typically seen in the growth of populations of humans or animals or bacteria. For an original amount denoted by A sub O that grows or decays at a rate r for a certain time denoted by t, the final amount capital A is computed by this formula. Capital A equals capital A sub O times the constant e raised to a power that is a product of r and t. Let us have this example 1. Chris is a researcher at the Center for Disease Control and Prevention, and he is trying to understand the behavior of a new and dangerous virus. He starts his experiment with 100 of the virus that grows at a rate of 25% per hour. He will check on the virus in 24 hours. How many viruses will he find? First, let us write our formula, and then let us list the given. Let us begin with the original amount, A sub O, and that is equal to 100. Next is the rate R, which is equal to 25% per hour. Let us convert this 25% into decimal. Let us divide this 25 by 100 and dropping that percent sign, and this 25 over 100 equals 0.25. Then the next is the time denoted by t, and this is 24 hours. Please take note that the rate and the time must be of the same unit of measurement. You see here, the rate is with respect to hour and our time is 24 hours. So we verified now that they are the same. If they are not the same, you need to do some manipulation for this unit of measurement for time to conform with our rate. And then let's go now to our computation. Using our formula here, let us do the substitution. So our A equals A sub O times E raised to the product RT. A sub O is now substituted by 100. E is a constant. Our R is the 0.25 and the T is 24. Let us simplify the product. We will have 0.25 times 24 is 6. So we have now in this line A equals 100 times E raised to 6. We will use our calculator to simplify this E raised to 6, and we will get this 403.43. Then times 100, we will get the answer 40,342.88. Let us round this off to whole number, so we have 40,343. And this is our final answer. Let's see this example 2. Radon does 222. decays at a continuous rate of 17.3% per day. How much will 100 milligram of radon thus 222 decay in 3 days? Let us begin our solution by writing the formula. Let us enumerate the given in the problem. First is the original amount. This is A sub O equals 100 milligram. Next is the rate. And we're going to write here negative 17.3% because of the word decays. And let us convert this percent into decimal. First, let us divide 17.3 over 100. The negative sign is still affixed, and we will have the final decimal as negative 0.173. Next is the time, denoted by T, and this is equal to 3. Let us check again that the units of measurements for the rate and the time must be the same. So the rate is per day and our time is 3 days. So we are sure that they are the same. We can now proceed with our computation. Listing again our formula, and let us do the substitution. Our A sub O is now changed into 100. The E is a constant. Our R is now negative 0.173 multiplied by T, and our T is 3. Let us simplify our power. Let us get the product of this negative 0.173 and 3. We will have this negative 0.519. Let us use our calculator to simplify this constant, e raised to negative 0.519. And we will get this 0.595115. Getting the product of this decimal and 100, we will get this 59.5115. And this is the final amount in milligram of radon dash 222 that will remain after 3 days. This is our final answer. Let us see this example 3, and this is calculating continuous growth. A person invested $1,000 in an account earning a nominal 10% per year compounded continuously. How much was in the account at the end of 1 year? Let us write our formula. Then let us list the given starting from the original amount. A sub O equals $1,000, followed by the rate denoted by R, and this is 10%. Converting our 10% into decimal, so we have 10 over 100, and this is equal to 0.1. Next is the time T, and this is equal to 1 year. So let us check again if our rate and the time are of the same unit of measurement. Our rate is 10% per year and the time is 1 year. So they are the same. We will now proceed with our computation. Listing our formula again, it is now here, and let us do the substitution. A sub O is now 1,000. E is a constant, we will just copy. R is now 0.1 times t, the time is 1. The 0.1 times 1 is simply 0.1. We will use our calculator to simplify the constant e raised to 0.1. And this is 1.1051. This decimal multiplied by 1000, we will get 1105.1. And this is in dollars. This is the final amount at the end of 1 year. This is our final answer. I hope you learned something from this video. See you again next time. Hi, math enthusiast. I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. See you all in e-DEOlogy community. And get this beautiful e-DEOlogy fun badge and be a member according to your interest as a bronze member, a silver member, or a gold member. We love to see you in e-DEOlogy community.